Hi, I'm Michael Marty, and I'm an assistant professor in the Department of Chemistry and Biochemistry at the University of Arizona. I'm going to be showing you today how to use the GNPS LCMS Dashboard for analyzing LCMS data. If you're watching this, there's a good chance that you're a student here at UA using this in one of your lab courses, but we're also going to be posting this publicly for anyone else who may be interested. So why use the GNPS Dashboard? Well, first, it can be run out of a browser, so each student can analyze their data on whatever type of computer they have. It's also free, and so we can have a lot of students using it at once with no licensing restrictions. Finally, it provides a user-friendly user interface that allows us to visualize LCMS data and MSMS data in a variety of different ways. So let's go ahead and get started. The first step is we're going to convert our data into the Mzml file format. So future and even current versions may support other file formats, including the vendor formats, but Mzml is great because it works on everything, right? It's a universal standard for mass spectrometry data. So to do this, we're going to use a program called MS Convert, which is part of the ProteoWizard software suite. MS Convert runs on Windows, so you'll need to do this on the instrument computer, or if you don't have access to a Windows machine, you'll need to do it there. So when we load MS Convert, we're just going to first select our file. I've put the file on the desktop here so we can easily find it. You see it's a thermo raw file. We click Open, and then we click Add. It will add it to our list here. You'll see it automatically sets the output directory for where the file was located. We're going to need to make sure it's set as an Mzml file, but usually that should be the default. But pretty much the default setting should work, so we're going to go ahead and click Start here. You'll see it will start to convert the file. It'll take a few seconds. But finally now we've got our Mzml file alongside of our raw file. Once we have that done, we can go ahead and close out of MS Convert and drag our, well, first, when we load the GNPS LCMS dashboard, you'll see there's a default file in here. You can go ahead and play with that if you want, but I'm going to go ahead and delete that out. And I'll post the links to these in the chat below. What we can do is just drag and drop our file, our Mzml file, into the program here. You'll see it'll take a few seconds, but it'll load it. We'll see it says mzspec local, and then give our file name with a bunch of random characters afterwards. So this is showing that it's a local file, an Mzml file, should match our file name here. And if we scroll down, we see there's lots of stuff up here that we can talk about later. If we scroll down, let's take a look at what the data looks like. So the first thing you'll see is this two-dimensional plot where we have retention time here on the x-axis. We have M over Z on the y-axis. And the intensity of the different M over Z is coming out with the color. Right? So we see we have kind of some contaminant ions with a constant signal here, a constant signal here, but we get a little bit of a spike here at 195, and we'll see this comes out. Each of these X values is where it's collected an MSMS scan, and we'll talk about that later. But this is the overall two-dimensional plot. It's a little bit hard to look at though, so let's go ahead and scroll down. This is the total ion chromatogram, or TIC plot. And the TIC is basically showing, as a function of retention time, how many ions are hitting our detector, the total ion count, right? Now you see it's got this kind of spiky pattern, and that's because we've actually created a scan method that alternates between positive and negative ion scans. And so the positive ions are going to come out here at about 1 minute, the negative ions are coming out down here at about 4. So we can filter this to make it a little bit easier to view, so we're going to go ahead and turn on the filter. We're going to set the polarity to positive. And what you'll see below is now our total ion chromatogram plot, but for only positive mode, right? We filtered out all the negative scans, which is why it now looks nice and smooth, right? So let's take a bit of a deeper look here. What we can do is if we want to see what the spectrum looks like at any point on this plot, we can just go ahead and click here, right on the plot. And you'll see up here it's going to update our MS1 scan. So this is the MS1 scan at scan number 61, which is a little over a minute into it. And you can see we've got annotated plots for, we got some ions down here at 74, but the main peak that we're getting is at 152. If we click over here on the second peak, you'll see now we've got a mixture of 152 and 195. Okay, so now let's say that we, clearly we have two different peaks that are coming off with two different retention times, but they're not perfectly separated in the total ion chromatogram. So what we can do is create what's called an Extracted Ion Chromatogram, or XIC. And so to do this, we're going to go up. There's lots of different settings here. we're just going to focus on setting the particular M over Z value that we want to isolate. So in this case, let's say 152. Right? So if we put in 152, what it's going to do is extract only the ion current from that 152 ion, not the total ion current, but just the extracted ions for those ions at 152, plus or minus a tolerance here of 0.05. So if we go down, we can now see this is the extracted ion chromatogram. We get this peak here, and then it dies off, right? Each of these little X marks where we've got an MS2 acquisition, an MSMS acquisition, and we'll talk more later about what that looks like. So this is now just the signal from this 152 ion. We want to integrate this. It actually is already done. It automatically integrates that signal, and if we scroll down, we can see here's the XIC at 152 for the given file, and here's the extracted area under the curve for this particular XIC. It'll show down here on the plot. Now, in this particular set of scans, we also have targeted scans for single reaction monitoring, or SRM chromatograms. Now, the way we've converted the data, it's going to put these as chromatograms rather than MSMS data. And so to do this, we're going to go ahead and just delete that out. I'm going to go up to the advanced XIC options. And under the Mzml chromatograms, you can see there's a variety of different things here. We have the total ion chromatogram, which we could plot. We also have UV and UV chromatograms from the 4 different wavelengths that our photodiode array detector was set to. This is the total photodiode array signal. But then there's these 2 SRM chromatograms. So we have one at 152. I'm going to go ahead and add that in. And one at 195. Now, this is an SRM, not an XIC, and that means we're isolating not just in the, we're looking at the first quad where it's isolating at 152, and the second quad is also isolating at 111. So this is looking at a particular transition from 152 to 111. So not just in the extracted ion chromatogram, it's the overall signal for the 152 ion. This is the signal only for the 152 breaking into the 111, or the 195 breaking into the 138. So if we click close, I'm going to go ahead and group these by file over here. And then if we scroll down, what we're going to see is we have our 2 chromatograms. This is the SRM for the 152 to 111 transition, and for the 195 to 138 transition. We can see the 152 elutes here, the 195 elutes over here. If we scroll down, we can see these are the 2 chromatograms. These are the 2 areas. We get a lot more integrated area in the 152 to 111 peak. You can see that also in this bar chart down here. So this gives us a really fast way to integrate these chromatograms, which will be useful in the data analysis that you're doing for quantification, targeted quantification in the lab. So finally, the last feature I want to highlight is the ability to look at these product ion scans for doing MSMS. And if we scroll back up, and you remember that we had for this 152 ion, we had these little X marks that showed that we were getting MSMS scans on those particular points. So to visualize this, we can go over to this 2D plot. We can find these 152 ions, and each of these blue marks here indicates a particular MSMS scan. So if I click on one of those, it will create here the same sort of extracted ion chromatogram that we did before, the XIC at 152, or in this case, it's 152.301. But down here, it's going to now annotate the fragmentation spectrum, the MS2 spectrum. So here we've isolated our ion at 152, and some of that still gets through. And then we fragmented it in quad 2, and then we've scanned in quad 3. So you can see we're not only getting the 111 fragment, we're also getting all these other fragments as well. So this allows us to look at, say, data-dependent acquisitions and look at the MS2 scans, so you can see that here. So this concludes the tutorial for today. I hope this was a useful intro into some of the basic data analysis features that we'll be using here in the teaching labs at UA. There are a lot more features in here that we didn't have time to talk about. It's a very feature-rich software. I'm sure other people are going to post more extensive tutorials explaining other ways you can use this. I'll close by thanking Ming Wang and Peter Dorstein, the other developers, for creating this free user-friendly tool for doing LCMS data analysis. And thank you for tuning in today. Good luck with your analysis in the future.